I'm Jacob. Everyone else will introduce themselves when they come up. Just a quick overview. We're going to go over some card games with how math's applied in that. Math games in media, specifically game shows, and then some math games in education. And then Jordan's going to talk about card games first.
So probably one of the most known card games that has math in it is blackjack, like Jay Ferguson did yesterday. And you get two cards, and you just want to get higher than the dealer without breaking 21. The next game is cribbage. It's played on a board, and you need to get either 120 points, or you can go all the way back. But each player is dealt 6 cards, and then you discard 2 of them, and you want to get you want to add up your cards to 15, get a flush, so it counts all 4 cards, and it counts 4 points. You want to get a straight, and then each total of your hand adds up to your pegs, and you want to just be the first to finish. The next one is a subtraction war. Each player is dealt two cards, and then you subtract, and whoever has the higher difference is the winner. This next one is 10, 20, 30, and it depends how many players you have. I just said if you have seven people, you'd be making like a row of 7 piles, and you just put 3 cards in each pile face up, and you just need to add them, either up to 10, 20, 30, just a multiple of 10. And if you don't have a multiple of 10, you just keep adding cards, and whatever pile that you have, the first person to get rid of their deck or pile would be gone. The next one is toss-up. Every person draws 3 cards, and you throw them in the air, and you only add up the cards that are face up. So if you threw 3 10s for some reason, and only 2 of them are face up, and the other one was face down, you'd only have 20. So these are all, I found this on the website that was just directly math games. There was 15 or 20 games on there that went from simple games like this into different division, multiplication, all sorts of different games you could actually use in a classroom if you're a teacher. And you could use it anywhere from elementary all the way up to high school if you wanted to. So the one game I'll be going in depth in is blackjack, and we all have a pretty good idea about what it is because of the presentation yesterday. But just like I said before, you want to get the higher card than the dealer, but without breaking 21. You can get exactly 21, but it's actually a lot harder to get since there's only 4 aces in the deck. The odds are always changing depending on how many decks you're playing with, what cards have been drawn already, how many people you're playing with, and what kind of rules the different house has. Basic strategy cuts the odds of the house winning from 70 to 80% to only 50%, and that's just physically proven, and people have ran through the numbers and everything. There are also other strategies that keep account, and that's what we were doing yesterday. That was just another form of it. There are other different forms where each card has its own value. So whatever card is played, that gives you an entire different number. And this is the basic strategy chart we all saw yesterday, and it just runs through on whether you want to hit, stand, split, or double. And just like I said before, it's always changing on whatever card's been played already, what cards are still in the deck, how many people you're with. And that's actually a calculator for the odds of the house winning against you. And if we have enough time at the end, I'll be going through that.
So now we'll go through math games in media, specifically game shows, and I think pretty much every game show has a small degree of math in it at least. I mean, even just keeping score technically is math. And then here's just a few game shows that have a little bit more math in them: Wheel of Fortune, Deal or No Deal, Let's Make a Deal, Who Wants to Be a Millionaire, The Price is Right, and Jeopardy, and I'm sure there's a lot more too. So we'll be going into Let's Make a Deal a little bit here. Monty Hall hosts Let's Make a Deal, and his famous problem, the Monty Hall problem, goes through this scenario. You have 3 doors here. One of them has a prize behind it and 2 don't. In this example, we'll be saying the prize is a sports car and the other 2 are goats behind the door, because I'm assuming everyone here would want a sports car instead of a goat. I guess if you wanted a goat, you could just get the sports car and sell it and buy more goats. But yeah, that's besides the point, I guess. But so you pick a door. So let's say you pick the red door. Then Monty Hall is going to open one of the remaining doors that doesn't have the prize behind it. So one of the remaining doors that has a goat, because no matter what door you pick, one of the 2 remaining doors is going to have a goat behind it. So he'll open that one, and then he'll ask you if you want to switch your selection. So the question is, does it matter if you switch? And just out of curiosity, who thinks that you should switch? So do the rest of you think you should stay, or you not? Who thinks you should stay?
I think it doesn't matter.
Doesn't matter? Okay. So let's look at the solution then to this problem. So let's say you never switch from your original pick. You pick the red door, you don't switch from it. The only way you're going to win the car is if you guessed the car on your pick. Because if you switch, obviously, then, you know, or you're not switching, I mean. So there's only a 1 in 3 chance of you winning the sports car, the 33% about. But if you always switch, so can you go back this side? So say you pick a goat and you always switch, then one of these 2 doors is going to have a car behind it and the other is going to have a goat. He'll open the one with the goat, which will make you pick the car if you switch. So go back. If you switch from your original pick every time, there's actually a 2 in 3 chance that you'll win the car, because every time you pick a goat, you'll win the car. So if you ever got on that show, I guess you should switch. So, yeah. And now, deal or no deal. I'm assuming most people know about the game, but I'll just go over it quick in case you don't. There's 26 cases up on the stage. They all have dollar amounts in them, which is like your prize winnings, anywhere from a cent all the way up to $1 million. So the contestant's gonna pick one of those cases to be like their case, I guess, like that's like what they're gonna win, but they don't open it right away. And then there's all the other 25 cases are all up on the stage. Then they start picking a certain number of cases each round. So obviously if they pick that case and it's opened, then you know that they don't have that value in their case. So after each round, the banker then, based on what's been opened, is going to give them an offer to buy their case from them. And the game will end either when they open all the other cases and get down to their case, and then they get whatever in their case, or when they accept the deal from the banker. So here's all the case values there, just if you want to look at that. And then, so then you can expect to win, you know, each one of these has a 1 in 26 chance of you picking it on your first pick. So you can expect to win, you know, 0.01 times 126 plus 1 times 1 over 26. And, you know, as you probably can tell, that's actually just the average, because if you just add them all up, divided by 26, that's the average. So that actually, right when you start the game, your expected winnings are a little bit over $131,000. So if you're, you know, if you're trying to kind of like do better than the average, you should try to get more money than that. So then through each round, you can actually keep calculating the expected winnings to decide if statistically you should take the deal or not. Because I don't know if you guys ever watch a show, but a lot of times people get these really good deals, but they might have like $1 million still on the board and they'll think they're going to win it. They'll keep playing and they'll end up getting their case for $5, say, and they could have gotten $200,000 if they'd have taken the deal earlier. So now we're actually going to play Deal or No Deal and go through, and go through like if we should be taking it. Search.